So, good morning and welcome everybody to webinar which we call Move from 2D CAD to BIM for Infrastructure. First, I will introduce myself. My name is Tomáš Lenvorsky. I am Senior Technical Sales Specialist AEC based in Prague, in Czech Republic, and being responsible for Eastern Europe. And the goal of this presentation is to give you overview where is Autodesk with BIM for Infrastructure and how you can move from 2D to really 3D, and not really only 3D but BIM. This webinar is connected with FIDIC, and in fact, FIDIC is an organization which organized recently a regional conference in Belgrade, and one of the main topics, of two main topics, was a road to smart infrastructure, and it was related to BIM. And FIDIC as an organization, they realized the importance of BIM, and here I gave some link there where you can read what FIDIC is thinking and how they are acquiring BIM and what is their recommendation to their members. However, I dare to mention a couple of things. One is that they really appreciate that BIM is basically moving, designing from 2D to 3D, intelligent 3D model with information, which will finally diminish the mistakes and omissions from the model, and not only this, that it will help to have a much better understanding for each and every stakeholder regarding to the project. And this is, I believe, very important thing, and I will mention it throughout the presentation as well. 3D BIM model is really important way how people can understand the project even before it's started, and that each and every information is shared with the rest of the stakeholders on the project. And the stakeholders are not only professionals, but obviously it can be also public. So then it's possible to prepare visualization and share the data with public much more efficiently than some 2D drawings like layout, profile, or cross-section. So let's have a look for BIM for infrastructure. In fact, if you look to web, you can find different definitions of BIM. BIM is coming from acronym Building Information Modeling, and definition which I like is that it's a really collaborative process which is driven by digital information, which means 3D model. And 3D model is, let's say, placeholder or basically container for information which are shared through the life cycle of the project, which means from the very beginning, from planning to design, throughout the build, up to the manage. Basically, this is what you can see on the picture. So please remember more information which are attached to 3D model and which are living through entire life cycle of the model. In fact, I heard another definition which I also like, BIM, like abbreviation for better information management. So basically, this is also the way how better to manage information about the project throughout the life cycle of the project. So, and if you look to BIM, so idea is to have model where all information will meet, and it's regardless of the source and also regardless of the profession. So it can be civil engineering, like road, rail, utility, structure. There is no road without a structure like bridge, tunnel, etc. Obviously, information from the survey, and this surveying information can be very different, including GIS, geospatial data, architecture, building, because you have no building without road and no road without building. And if all the information are gathered and stored in one model, then people can benefit from this model different way. So obviously, then they can derive project documentation, basically traditional project documentation like 2D drawings, which are still necessary to deliver the project. They can use quantification. They can really see what will be sequence of the project, coordinate, visualize it, how the project will look like in the future, and also go to the scheduling, cost estimation, and connect it to ERP systems in the office, etc. So BIM model has a really big benefit that all information, the entire 3D model with all information is stored in one location, and then the data can be shared and derived from this model. And what I would like also to mention that BIM is not only about technology, and this is very important to mention. BIM is really change in mindset of the people. So it's people are very important in this process, and also the processes within the company. So technology, I must say, is only part of the change, and honestly, the most important is changing the mindset of the people and processes within the company, which, based on experiences from other countries, it's in fact the most time-consuming job. Which means that if you really want to acquire BIM, you should start as soon as possible being able to have BIM implemented in your company. And more, what I want to mention is we already went through the changes in the 90s, in early 90s, when we were changing from drawing boards to 2D CAD, which in fact, according to my opinion, the change was not so big, because either you were drawing lines using pen or pencil and straight, while ruler, sorry, and then you move to the computer where you were drawing the line with mouse. But here it's really changed in the process, because 3D model is very different, and more importantly, adding more information at the right time of the project is very important, and this is something which will really require a change within the company. So with that, let's have a look what will be the agenda of our webinar. So I will start with conceptual design, then we will look to the data preparation, and obviously with the limited of the time, I will not show everything, but you can imagine that I will be talking about road design, I will be talking about structural design, but obviously there can be also utility design, railway design, etc., etc. There can be many different things, many different assets of the infrastructure project which can be designed in our products, and all these professions, all these parts will meet in a coordination process. And all the time I will be talking about analysis, because you should be able in any stage of the project to make analysis, either if it's conceptual or detailed design or even coordination. So you should make analysis of your project to have the best output from the design. And also, always you need to make and collaborate, which means that you should be capable of making the design way that you can always collaborate. You can also you can always share and collaborate with your information with other stakeholders. So let's have a look what is offered by conceptual design. So if we look at the conceptual design, so it's really early stage, and maybe you don't have enough information yet about existing model. So you should be able to create existing model very quickly, and you should be able to create a design. So if I'm talking about creating design, then I'm talking about really different assets like rails, roads, so on and so forth. And then you should be able to explore and evaluate alternatives. What does it mean? That obviously in the planning process you can have different alternatives, and you should be able to have all these alternatives within one model and being able to share these ideas with other stakeholders. So basically one model will host many different ideas, and then obviously at the end of this process you will select one and you will continue to make detailed design. And let's have a look how we can build a design context. So we are in the InfraWorks, and here it's very easy to just select the area, and you can select area basically using some rectangular or polygonal shape, or you can just import shapefile like here, where you will say, okay, I want to create this part of the land. So here defining the size, so it will be nearly 33 square kilometers, and the part which will be created for free in matter of minutes. You will get a 3D DTM model, images of the ground, buildings, and roads and rails and waterways. So after virtually after a couple of minutes, you will receive email that your model is created in cloud, and then you have just to download these data. So it will take 1-2 minutes to download it, depending on the size. Obviously, if you are having 5 square kilometers or 150 square kilometers, there is the difference depending on your download speed. But then you will receive really 3D model of existing ground. And here in this example, we, for example, have our own orthophoto, basically the pictures of the ground. So we will just drape this orthophoto from other sources, but you will get it if you need it from data, for free data available. So it's really up to you how you want to combine. What I want to say is that you can combine free data and available other GIS data, because you have in Romania WMS, WFS portals where you can really work with the data or shape files, and all this information can be shared or can be uploaded. And you can see that there is a lot of other possibilities which you can implement. And for example, here I downloaded SQLite data from a web, which were also for free for the particular area, which is in fact Nature 2000 areas, which I shouldn't affect with my design. So I want to bring it in because this is important information for me while designing. And you can see that we are creating what we call coverages. I stylize it with green color, and I know, okay, this is the area because this is in mountain area, so I shouldn't pass through this space because this is under UNESCO heritage. So and then because these are GIS data, so with all GIS data, what I can get information, what is it about, so I know why it's a protected area, and I can really dig into the information, not only what is this area, but what is the name of the street, and so on and so forth. So having this data already created, I can start with my detailed design. So in the meantime, I brought here also cadastral information. So you can see that I have here limits of each and every parcel. And now very quickly, I can start with my row design. And the idea of this project is that I have to create a new bypass through this village, but I'm in very restricted area. You can see that I have here railway, I have town here, and from both sides I have this Nature 2000 area. So I'm really in a restricted area, and I will have to be very careful what and how to design. And now I'm sketching, and I'm really saying sketching the road in this 3D environment. And if I say sketching, it really means that I'm doing it not only 2D, but really system is doing in 3D. Now you might have question, okay, I mentioned that I shouldn't pass through this green area because it's protected area. Yes, you are right, I know about this. So what I will do is I decided that I will create a tunnel here because I'm really in a narrow space and I have to go here inside under the ground. So just selecting different style, and I'm saying, okay, from here to here, let's try to make a tunnel. So tunnel has been created, but obviously this should be not on the ground, but below the ground. So let's have a look what we can do. So I open the profile, and then very easily I can drag and drop these points, or I can add intersection points to really drag this road under the ground to really have a tunnel. And as easy as you can see, it is to create this road. And obviously at the beginning there is railway, so I should also think about having most probably bridge here, because it makes much more sense to me. And you can see that I can work in 2D in profile, or in reality I can also grab the point in 3D and move this point in 3D. And you can see what is the reaction of the system. Immediately I have system knows that there is railway, so there is space. And now I'm adding bridge as another structure. I have a road, tunnel, and let's have a bridge as well here. Again, the very same idea like this tunnel. I'm saying, okay, from here to here I will have a bridge. So system will create a bridge structure for me, including piers, abutments, and everything. So I can check what are the possibilities. So I can use different precast or steel bridge. I can use different design standards because this is structure. I can calculate this in cloud, or I can select different piers. So basically what we have the library of different parts of the bridge, not only piers obviously, but this is example of piers. I can select different pier. I can rotate it, I can move it very easily, interactively through the model. I can change any structure, in fact, of this bridge. And then let's have a look also if the ray will be able to pass, so I defined that the clearance will be 5 meters, and now I just open automatic option just to move vertical profile of my bridge automatically up, and having all this information modified. So you saw that very quickly I can create a really conceptual design, and in any time I can make analysis. And here is example of analysis like visual intrusion or side distance of my road. So if I'm pathing with some design speed, if I will be able to, or the driver will be able to have side clearance along the way. And in the meantime, just clicking the road, I can make a visualization. So defining position of the driver and where he will be seeing, I can very quickly drive through, and I can use it for example, public hearings, or share this idea with other people. So you saw that it's very quick and very easy to do visualization from this 3D rich model. And obviously I can define different day and night time to see what will be, for example, shadows. I can make a simulation of the traffic and other analysis, volumetric analysis, for example, to have really better idea about my design in early stage. What are the benefits? Benefits that we can create very easy existing model for free. Matter of really minutes to have a model, and then you can add another data if available, GIS, CAD data, point clouds. So anything you have, you can bring in, or you can connect to the database, the system, and then you will have all information available for design. Then you can very quickly create different variants, different alternatives of your design, and then it's very easy to share the ideas either with some movies or via cloud if you will give access to the people. And then we can work with really large models. So I was working with about 40 square kilometers, but you can imagine that you can have 150, as I said, and more kilometers, and you can very easily work with this. So let's move further. From conceptual design, I will move what I call data preparation. And the point is that with data preparation, there is no design without GIS. So let's have a look at how we can bring other GIS data to be ready for detail modeling. And not only GIS, we will not only consume GIS, but we are using these GIS formats without conversion. We are just bringing in this data, visualizing it, stylizing it, and then based on this data, you can start your design. And as I mentioned, the data can be not only, for example, GIS data, but other surveying data, also, for example, borehole information, laser scanning, etc., etc. So basically, you can have very different sources of existing data, and all this you can bring into the system. So let's have a look quickly how we can prepare data. Now I am in Map 3D, which is in fact part of Civil 3D. So I'm using functionality which is belonging to Map, but it's part of AutoCAD Civil 3D. And now just defining coordinate system to be ready for design. And I brought here GIS data, and I can stylize it as I mentioned. So basically, I don't like this color. Let's choose different color based on requirements, and then let's add some labels. So text labels, for example, and all this information are coming from GIS data. And as I said, without any conversion, I have parcels with parcel number and everything in Civil 3D immediately. Then let's connect to GIS data. For example, here's example of Oracle, but as I mentioned, we can connect to WFS, for example, and other data sources. WFS, you can see the databases here which you can connect to, or just import shape files, and then just saying what I want to see on my screen. And here it is in fact from Poland, because I had data from Poland, and you can see that I can really work with entire Poland in one drawing and very efficiently. So this is not any big deal to really work with large data. But obviously, because my design will be only in this part, so I can filter the data. So what I will do, I will define the boundary, and I will say, okay, just show me everything within the boundary, or better said, maybe all data which are touching this boundary. So I have all this information here already filtered out what I need, and yeah, I can add other data sources, and what we can do are also the queries. So basically, I don't have to bring everything from the database, but only what I need. So basically, I'm doing what we call query to the database, and only needed data are displayed with all information. And you can see that we are bringing not only, let's say, picture from GIS data, but also other information like data. And obviously, this data can be used and converted for further use. Now I'm just doing, what will be on the top, what will be on the bottom, and so on and so forth. So all the information can be sorted, doing also the priorities, what will be the first, what will be the second, etc., etc. So, and another example connecting to WMS data, just very quickly saying what I want to bring in from WMS services. I just adding to the map, and I will have it really in a matter of minutes. So all the information are here. So just sorting it out, sending it to back a little bit, because I don't want to see it everything. So we prepare the data. So let's have a look what we can do else. As a just really example, what we can do is we can create based on borehole information which were imported and displayed using functionality available in Civil 3D. I can create different borehole layers and obviously surfaces, and then very quickly I can create not only views on the boreholes but also sections. I can make hatching of different information, and it's not only about picture, but then later on this data I can use for my design. All this information I can see in longitudinal profile, cross section. I can target these surfaces using our assemblies, and so on and so forth. So basically I can add more and more information. I didn't touch laser scanning and other data sources, but all this information are available. So what are the benefits? As I'm used to say, there is no infrastructure design without GIS. and we have to be able to bring this GIS into the model, so we can create different surfaces from different sources, so that we can use really variety of GIS data to bring it in. We can use different styles for GIS data. We can use really GIS data which are for free available on web, and we can connect to these services. Again, we are talking about large models which can be brought in, and we can create different subsurfaces, for example, from borehole information or from laser scanning, etc. So let's move to the detailed design and analysis. So during the detailed design, we are capable of creating road, trail, utilities, I mentioned, site design, and so on and so forth. Basically, what I'm saying is that we can design anything what is modifying, in fact, existing 3D surface. And based on this design, we can do different analysis like volumes, areas, swept path analysis, visibility. Again, other ways how to analyze our detail design, being able to really have the best design as possible based on obviously other constraints like GIS information, etc. So let's have a look what we can do during the road design. So what we can do is we can bring and we can start our design based on templates, which means that we are delivering what we call Romanian country kit, and you can start your drawing based on Romanian standard, because the template is bringing in all styles for layout, section, and profiles based on the local standards, and you can really start immediately with this. Now, what is also idea of BIM is that the data are flowing throughout the life cycle of the project from one designing tool to another designing tool. And don't forget that we already have this conceptual design. So what I'm doing here based on map, which is brought in the background, so I'm defining which part of this conceptual design I want to bring in. So let's make this map off, and then you can see what I have here. I have, for example, this bridge which we designed in this preliminary stage. I have alignment, profile, basically these data which are coming from this original stage. So you can see alignment, profile, and so on and so forth. So going to the detailed design, we can create what we call assembly. We have here a list of sub-assemblies which can in fact form assembly, and then what we have, if you are not satisfied with the library, for example, here I was using sub-assembly composer to create specific typical cross-section for a tunnel. So you can see that we can target it, we can play with this depending on super elevation. So you can also create your own assembly to be able to really fulfill design needs. So let's try and let's create what we call corridor. So I was saying, okay, now I want to create this alignment and profile coming from conceptual design. I will target existing ground, and we can start to create our design. So now you can see it's just fast forwarded, but you have to specify, okay, from here to here will be normal road, from here to here will be bridge, etc. And then I can create a cross section. So let's have a look how my design is looking, and system is doing automatically based on rules which are basically built into the assemblies decision, where is cut, where is fill, also to make, if you need to make a slope of the fill based on the height, etc. So there is a lot of things which we can do and build our model. So now you can see that I have model where I have cut, fill, cut, fill, tunnel, all this information available. So I have all this information, and what I want to bring in now are these buildings which we created, or which system created for us in this preliminary design, this conceptual design. So I brought in my buildings because I just want to show you what is possible, and obviously now I see that my fill is not the most clever one, and these people here in these buildings will not be very happy with my design, because it would mean that I have to destroy these houses. But what we can do, just very simply, change the assembly. I put there some retaining walls, and then I'm saying, okay, now use this retaining wall as a assembly, as a typical cross section. And in fact, I'm also targeting geological layers. So basically I can target geological layers, because most probably the bottom of, or the base of the retaining wall must be in this particular rock area. And you see that the dynamic model is changing immediately everything, not only layout, but also cross-section view, volumetric calculation, and everything what is related to this. So I can really very quickly create or recreate the data. And now let's talk more about BIM. So we have 3D model, but I was saying that, okay, BIM is about information. So now let's have a look how we can bring in some information inside into the model. So now I'm creating a model which I want to send to the construction site, for example. So I'm saying now, because I'm preparing data for construction, and on construction site they want to build maybe using it different regions, maybe from station 0 to 300, then from 300 to 500, basically different sections of the road. So I'm preparing these data for them. And then I'm also adding information, like for example, I can add here information, who is designer, etc., etc., and to really create 3D model based on my design. And now let's have a look. I have, for example, here retaining wall. So I have retaining wall, and let's have a look to the properties, basically to the information, to the metadata attached to this. I already know that it's from station to station, what is the volume, but now I can basically enhance or enrich this model with other information. And for example, I prepared in some template who is the designer, who will build it, what will be the cost, who will be the designer. So all this information can be built in, and you can really create whatever you want. It's just example. And all this information from now on will be living with this project, and can go to the construction site, can go to the asset facility management, etc., etc. So having this rich 3D model with information, I can send it to the Navisworks, which is in fact from our perspective like BIM coordination model, because at the beginning I said that all information should meet in one place, and this is the place where all this information are stored, aggregated, and with all metadata, with all information. And in fact, here is just a quick view, and I will be talking about this because collaboration is an important part. So we share this information throughout cloud services, and we can share different file formats through this. But I will talk about this later on, but just realize that we have to collaborate all the time throughout the life cycle of the project. And I was talking about different analysis. So here is another possibility what we can do. We can analyze, for example, swap path using swap path. So we have different design vehicles, including Romanian standard vehicles, plus some non-standard vehicles like oversized vehicles, and we can check if our design will meet the criteria that, for example, this track will be capable of passing through our design. So in fact, you see that here it doesn't work very well, because if he is using the lane for going right, so there is trouble. So I can try, and okay, if I will allow him to keep this line, so will he destroy my my island or not? So basically all this information I can change and modify, and then I can visualize it, so I can also check the visibility, what will be the driver visibility over this area, and so on and so forth. Again, it's very important in any stage of design being able to make analysis, and also to prove it, to report it. So basically now I'm showing what kind of vehicle I was using for analysis, and then obviously I can share this information, and I can visualize it in 3D so very easily. Here is another example. I have some site design, basically some, for example, supermarket, and then some track has to come, and he has to be able not only to get in, but also maneuver inside, so going back and forward within specified area, and I can very easily check if it's possible or not. So just another example what we are capable of doing, and check if system will be or this track will be really capable of coming in and being able to park there. And I will be in, or the driver will be in slight trouble, so he will have to go a little bit left to being able to later go right. And then you can really very easily to visualize and to prove that, okay, this design is correct. And this is a very important thing, being always capable of showing what is possible. So let's move forward. What are the benefits? So basically we can use the data from previous stage, from data preparation, from conceptual design, and really it helps with any infrastructure project, rail, road, site design, so on and so forth. And it's based on dynamic 3D model, which means if I do some changes in any part of my model, it's automatically propagated through the rest of the model, and not only this, but also through the documentation, because the documentation is just a result of a 3D model. I can do any analysis. I have Romanian standards built in, so all the information are available just to start. And then I can export model, really 3D BIM model with all information for subsequent use. So let's have a look quickly to the bridge design, because there is no road without structure. And if we are talking about structure, I'm talking about bridges, tunnels, retaining wall, and so on and so forth. And what we are capable of doing is to create not only rich model, but also deliverables, which means, again, 2D drawings, annotation, and so on and so forth. So just I will do it quickly because we do have some constraints of time. So let's have a look. Now I'm playing the role of not road design, but I'm at this point bridge designer. And this bridge designer, what he has to do is to use different tools. But again, he should be able to bring data from previous stage, basically from the road designer. So from road designer, I have information: where is my center line, what is my profile, what is my edge of travelway, basically shoulders, whatever information are necessary. And what we are doing is just bringing this information in and taking this information into the model. And in fact, I have immediately points which are in fact defining my edge of trailway, my center line, and so on and so forth. And based on this, what I can do is I can create a 3D model, which means you see that in Revit, in fact, now I have my 3D model. And now it's really depending on the cross section which user is defining, what is his typical cross section and how it looks like. And I have all information based on road design, having elevations, coordinates, everything in synchronized with my road model, because it's again very important that all informations are related to each other. So X, Y, Z coordinates are really the same. And then the bridge designer can do his job, because okay, maybe he needs a bit more complex model. So maybe there will be another objects like barriers at the edge, so other information, different shapes. So all this information, so you can see that now I changed the profile of the bottom of this chamber. So this bridge is not only in curve and horizontal curve and vertical curve, but I'm changing it also in profile itself, so the chamber is changing based on distance from the start and so on and so forth. Basically, what we are capable of doing is to bring in different conditions, and based on this condition, we can just rerun these scripts and create more information on the bridge. So you can see the barriers at the end. Again, we can annotate it, we can prepare it for deliverables, and we can also do reinforcement, rebars, and so on and so forth. So we have to model, we have tools creating model, and then have a look, for example, to layout and etc. So making cross sections just to see how the cross section will look like. Just really 2D drawings are just the result of rich 3D model. Yeah. So all this information are here. So adding some abutments, piers, again, this is based on intelligent families, and all these families are parametrical. So if there is some change, so it will be automatically propagated throughout the design. And here is just example how to make rebars. In fact, if I have 3D model, then I can add these rebars manually, or using some programming language just to do it automatically. So I specify where I want to have it, and you see really it's within seconds system will create reinforcement based on my criteria, and everything in 3D. So again, rich 3D model is helping you to create more and more details, and obviously now you can create drawing deliverables based on this reinforcement. And how it can be used basically on the construction site. If they have all information available from the structures, then you can imagine that it can go even further. It's just example, somebody can attach on the while preparing this for the construction site, this reinforcement. They can add QR code or barcode, and then this barcode can be used on the construction site. They can read it and they immediately know in which part of the project this barcode is supposed to be, and they can deliver it exactly on the site. Because then it's really again the result of the rich BIM model. Just scanning the code, as you can see here, they know in which part of model it is, and they can check not only model but also reports, drawings, and everything what has been created in Office with bill of materials and so on and so forth. So what are the benefits? Again, we are reusing data from the previous stage. We have advanced design tool to create really intelligent structure model. We can derive or create very easily to documentation, reinforcement modeling. We can implement very quickly changes into the design, and everything is based on dynamic parametrical model. And last but not least, it's also connected to the other professions. So basically, then this model can be brought into this BIM aggregated model where all information will be shared. So, and let's talk about coordination and collaboration. So why it's important? Because we want to have one model from which we want to derive all information. And obviously, if there are different stakeholders on the project, we can create clash detection because maybe they don't have enough information about everything. We can simulate the construction, and we can add another information to the model, because as I said in the beginning, so BIM model is about 3D model plus information, but this information can be added throughout entire life cycle of the project in any stage of the project basically. So let's have a look how we can collaborate. So what is Autodesk offering is BIM 360 portfolio, which is in fact cloud-based services where we can upload, for example, different file formats, and they can be visualized. You can see now that there is different variants variants of the same model, how model developed. And not only this, we can visualize it, we can get all information which has been added to the project throughout the life cycle. And what is important to mention, this tool is based on internet browser. So basically no need to install anything, just open browser, type your credentials, bring in data, and then you can share this data with other stakeholders. And these stakeholders, they don't need to have any idea about your designing tool. This is the most important thing. And then, for example, here, what we can do a live review. So basically, based on these tools, obviously you can imagine that this is on two different computers. On one computer, I'm doing something, and the other person somewhere else can view what we are, and I can show him what we are discussing, and having again all information available in the project. So all this information are available, and we can work with this. Yeah, and I can see obviously different activities of my project. What I can also do, I can upload PDF, for example, to the cloud. So basically I have PDF file, how to compact the asphalt as an example. So I want to add this information to my model. So I can go back to tool which is called Navisworks, where we can aggregate the data, and I will just select my asphalt layers, being, for example, chief designer, and I will just link it to this file which I put to the cloud. So basically, again, creating more and more, or adding more and more information to our model. So I will make hyperlink, and I will connect it to this file. And as a result, if I have this model in cloud, anybody using this model can see the same information, not only model, but the same information, regardless where they are located. They can be located in office, or they can be located on the construction site. And what I should mention is that we can work with this even offline. So basically, if you go on the construction site with your mobile device, you can download what you think that will be needed, and you can work there. Yep. So here is mobile device, and the very same experience like on a desktop, that you can browse into the data on your mobile device, and you can work with this. And again, you choosing it, you will see all information. But then, if we are talking about collaboration, it's also about adding, some comments, because maybe I'm on construction site, I see what's going on, I see all the information about the model, but then I find some mistakes or something, So basically, what I can do is I can add comments to this model, and because it's stored in cloud, then obviously everybody who has access to this model can view it. So just adding some markup, some comments. I will type, okay, maybe it's too high. So maybe we found on the construction site that this is not really easy, this retaining wall to build, So just example, really. I can add other information, and then anybody who is, for example, in office, he can open it and he can see what I put there. He knows who did it, when, and we can do also, obviously the other person can make its own comment, and so on and so forth. So, coordination. If we are talking about BIM, it's about rich 3D model, and here I have more information designed in Civil 3D. In fact, I have not only road, bridge, and tunnel, but you can see I have here also railway, I have here also drainage system, and all this information are aggregated into one rich BIM model. And just let's have a look. I hide it existing ground. You can see that I put here also, for example, street lamps to make light for lighting the bridge, and so on and so forth. And the person who has no clue about designing tools, he can very quickly check in really friendly environment, for example, distances, clearance checking, and being the chief designer, obviously I'm not very happy about this 2.2 meters clearance between the bridge and railway. So basically I found that there is some problem, so and I'm communicating this problem with other people. So I communicate this problem, and these people are sending me just new information, and I'm just refreshing the model. And this is the point. I just got the new model, I refresh this aggregated model, and everything is changed automatically. So now, most probably, it's much better, and my shortest distance is 5 meters. So this is what I expected. Nice. So we can go further. Just showing capabilities, how easy it is to update model in any stage. What I want to also to check what will be the scheduling, the construction scheduling process. So to each object or group of the objects, we can add time and to say if it will be constructed or it's just temporary construction and so on and so forth. And then we can visualize how it will be constructed. So basically here I have different stages of my design, stage 1, stage 2, stage 3, and then I see how the progress will be done on the construction side. And obviously combining anything, it can be drainage, rail, road, bridge, because I have all information in one model. And having this, I can run analysis and show it to other people. So basically having this, I can go to Timeliner and attach the timing to each object. Let's go and let's simulate it. And in any stage of this simulation, I can see how it will be built. So first this drainage, then road, and so on and so forth, basically depending on this, connecting obviously to existing pipe system. And in any stage, I can stop, I can go forward and backwards to see what will be done in this particular stage. And I can see the day and week where it will be developed. And also all information which has been added to the system are available. So you can see it here. So I will go further and we can do quantification. Again, person who has no idea about designing tools, he can do quantification here in one model. So he can say, okay, now I want to check how much asphalt I need in the first stage, how much concrete I need in the first stage of my construction, for example, for retaining wall, and so on and so forth. He has all this information and he can really make a right decision, for example, on the construction side, what and how it will be built. And obviously we can do much more as far as quantification is related. So you have all this and all layers of the road, not only, for example, asphalt, but here is example how quickly he can get information about asphalt. And again, within the first stage of the construction, because I said, okay, first we will be this 300 meters. So how much asphalt is needed for this first 300 meters? Then he can export it to Excel sheet. And this Excel sheet can be connected, for example, to ERP system or to other systems using within the company. And last but not least, what we can do is clash detection. So basically, I can say, okay, I have existing pipe and I have road, and let's check if within the tolerance half meter, if there is some clash. So basically, even if I'm within half meter, system will give me clash, and system will automatically go through the model, and system will find all issues resulted from clashes. So I can go through this just clicking on each and every clash, and system is basically zooming in into this. Then we can create a report. We can do switchback. So basically system can automatically switch to the source drawing in Civil 3D in this case, because I design in 3D and I can have all information available. I can change my design and then update my model to see everything what's going on, and making reports, just to share it with other stakeholders. So what are the benefits? So we have collaboration in cloud, no need to install anything. Versioning is automated, so you have track of all versions of your design on any device, basically on your desktop, on your mobile. We can use it large data, it can be visualized. It's really easy to use, no need some long training to use this type of tools, and the access are defined based on the permissions. Last but not least, visualization. For us, visualization is really just the result of 3D model. And you can do visualization in any stage of your design, after the preliminary, after detailed design, using the coordinating model. And you can use really different levels of quality. It can be very quickly and simple visualization, but it can be also photorealistic visualization, which you can use for presentations. And here are just sorry, it was quick. So here is just an example of some really nice visualization made in Doha for the project, where you can see that it's really photorealistic visualization with car movements and so on and so forth, with different materials. So this is something which can really help to understand what's going on the project. But in our time, we are also going forward, so we can do augmented reality or virtual reality. So here's example of virtual reality that people can experience really a rich 3D model using for example, here it's Oculus glasses, and people can look really and they can walk through the model very easily. So something which really help to sell the project and to understand the project. This is the most important thing. So, and in fact, I already covered visualization. It's easy communication. You can have really immersive experience of your design. It's additional value for your project, because giving visualization, it's really, in fact, simple, because it's just derivative of your 3D model, but it's really helping you to sell the project. So, summary, what you have seen different stages of your design, from conceptual design preparation, then we went through road and bridge design, collaboration and visualization, and always we did analysis and collaboration, so on the project. So this is really important, that collaboration is each and every stage of the design. And what are the benefits? Obviously you have different stakeholders, so what are the benefits for designers? Really fast changes. He is using the same data again and again. Analyses are automated. It's just a result of the model. He can use coordination and have the better understanding if there are some clashes. And last but not least, we are still creating 2D drawings, so you are able to create automatically drawings from your design. For the construction company, basically he can detect any mistakes, coordinate model very easily. He can do construction simulation based on how it will be really constructed. He can check the clashes in any stage and just to communicate it to the designer to have really better outcomes and not finding the clashes while constructing. And he can very simply communicate this with construction site. And for investor, he has complete model with all information available. He can control the budget, scheduling, so he can check what is the current stage of the construction and what it really should be at this point. And last but not least, he's preparing data for managing assets, basically to facility management. So, with these benefits, I'm just about to finish my presentation, and just I will look if there are some questions. Please, if you have any question, please use questions and yeah, please feel free to ask and yeah, you have my contacts or viral contacts. If you don't think about any question at this point, please do not hesitate to send us email to give us feedback what you need to know more, because obviously this presentation was really summary about BIM, how we see the BIM in really in accordance with FIDIC, you know, how we can help you and be really efficient in your design and being able to do much more stuff. And really, FIDIC is looking after this, and they are going this direction. And what I want to stress as a last point is what I in fact said at the beginning. Please do not wait. BIM is here. BIM is really moving forward. And if you wait and you will wait, okay, let's wait what will happen next year, how it will develop. What I'm saying to you, and this is my experience from other companies across the Europe, is that implementing BIM takes time. And if you are waiting, then you can be maybe late to implement it because this takes some period of time. And we already have customers who were asked to create the model, and they were not capable, and they lost big projects which could help them, to make much better revenue. But they were not basically capable and ready to go for BIM. So, and this is my main message, because don't forget, technology is only part. A lot of changes is also waiting on your side with people and with processes. So this is my message to you. And again, still waiting if there are some questions. If not, please do not hesitate to contact us, me or Viorel, via email. So with that, I don't see any questions at this point. So with that, thank you very much for your attendance, and I hope you found it useful. Thank you, and have a good day. Bye bye.